Let's go over this question together. Assuming ideal solution behavior, what is the freezing point in Celsius of a solution of nitrobenzene C6H5NO2 in a 0.25 kilograms of benzene, and we're given a lot of information about benzene, if the solution boils at 84.2 degrees Celsius? Now, let's summarize the information given to us and what we need to find. So we know that we need to find the freezing point of the solution, and this solution is a solution of nitrobenzene in 0.25 kilograms of benzene. Next, we're given a lot of information about benzene. First of all, we know that Tb, which is the boiling point of benzene, is 80.09 degrees Celsius. Next, we are given Kb, which is the boiling point elevation constant of benzene, that is 2.64 degrees Celsius per molar. Next, we're given Tf. Tf is the freezing point of benzene, and that is 5.49 degrees Celsius. And lastly, we're given Kf. Kf is the freezing point depression constant of benzene, that is 5.07 degrees Celsius per molar. Next, and finally, we're given the boiling point, or Tb, of solution being 84.2 degrees Celsius. So now, before we get into solving this problem, let's go over a little bit about what effects does adding a solute into a solvent have on the boiling point as well as the freezing point. So when a solute is added into a solvent to form a solution, there will be an increase in boiling point and a decrease in freezing point. And so the boiling point of the solution is going to be equals to boiling point of solvent plus delta Tb, which is the boiling point elevation. And formula for the boiling point elevation is delta Tb equals Kb times molality. Next, we have freezing point of solution. That's going to be freezing point of solvent minus delta Tf, which is the freezing point depression. And formula for freezing point depression is going to be equal to Kf times molality. And so in our case, we'll need to find the freezing point of the solution, and the formula for that is going to be Tf of benzene minus delta Tf. So we are given the freezing point of benzene being 5.49 degrees Celsius. So what we do need to find is delta Tf, and the formula for that is delta Tf equals Kf times molality. We know value of Kf from the information given. That's 5.07 degrees Celsius per molar, but we do need to find molality. And so the formula for molality is going to be mole of nitrobenzene divided by kilograms of benzene. And so we don't know the value of moles of benzene because no information is given to us on that, but we do know that the kilograms of benzene is 0.25 kilograms. And so from here, we know that we cannot calculate molality directly from this formula. But what we can do is that we can find molality from delta Tb, from the boiling point elevation. So now let's look at the boiling point of the solution. So boiling point of the solution is going to be equal to 84.2 degrees Celsius. That's the information given, and the formula for that is going to be boiling point of benzene plus boiling point elevation. And so from here, rearranging a little bit, we'll get boiling point elevation equals boiling point of solution minus boiling point of benzene. And that's going to be 84.2 degrees Celsius minus 80.09 degrees Celsius, and we'll get 4.11 degrees Celsius. That's going to be boiling point elevation. And from there, so looking back into the formula for K delta Tb, we know that is equal to Kb times molality. Now that we want to find molality, we can rearrange the formula to find molality from delta Tb divided by Kb. And that's going to be 4.11 degrees Celsius divided by 2.64. That's going to give us 1.56. That's going to be the molality. So now circling back, freezing point depression, we got that's going to be equal to Kf, which is 5.07, times molality, which we just found, is 1.56. That's going to give us 7.91 degrees Celsius. That is the freezing point depression. And so now finally, let's go back to finally find the freezing point of the solution. That's going to be TF of benzene, freezing point of benzene, minus delta TF, freezing point of depression. That's going to be 5.49 minus 7.91. And we'll get a value of negative 2.42 degrees Celsius. That is going to be the freezing point of the solution. Thank you so much for watching.